multiples. What would we describe as multiples? Okay, so it's basically the result of multiplying our numbers, okay? So the result, okay? As in, like, if I do 2 times 3, 6 is a multiple of 2, 6 is a multiple of 3. It's the result that I get after multiplying, okay? So the result of multiplying by an integer. Stop. All right, so integer. Since I'm using this very fancy word, what's an integer? Anybody know? Integer? All right, so an integer is a number that doesn't have a fraction with it, or it doesn't have a decimal. So 2 is an integer, 2.1 is not. 5 is an integer, but 5.5 is not, okay, because it has the half, okay? So integer, we're talking about whole numbers, and they could be positive or negative. So -3 is an integer, okay? All right, least common multiple. How can we describe that? Can anybody think about putting that into words? Anybody? All right, how about this? What's a synonym for least? Synonym for least. Okay, how about this? What if I, instead of saying least, I said the smallest? Would you agree that least and smallest are synonyms of each other? Okay, so it's the smallest positive. Okay, we're going to deal with positive numbers, not negative numbers yet. Okay, so it's the smallest positive number that is a multiple of 2 numbers. And I'll say 2 or more numbers. All right, so for example, you've got 2 and 3. Does anybody know what the least common multiple would be of 2 and 3? 6. All right, so now, this is how we get it in case you were not able to say 6 as quickly, okay? Multiples mean that we are going to multiply. We are going to multiply until we get a number that both lists have in common. Okay, so the common part for least common multiple means it has to be in both lists. Okay, so I start with 2 times 1, which is 2. Then I go 2 times 2, which is 4. 2 times 3, which is 6. 2 times 4, which is 8. 2 times 5, which is 10. And now I'm going to do the same thing with the 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. All right, so now, taking our definition of least common multiple, what's the smallest number that is basically a multiple of both 2 and 3? So what's the smallest number that appears in both lists?
6.
Diana. Diana says 6, and I think I heard some other people say 6. All right, so 6 is our LCM, and Diana had given that to us earlier as well. Okay? All right, so we're trying to find the smallest number that both numbers go into. All right? So if I were to do B, what numbers should I go across for 4?
1.
Not 1.
4.
4. You're doing 4 times 1, which is 4. Then what?
4 times 2.
8.
4 times 3, 12.
4 times 4?
16.
4 times 5.
24.
All right. Do the 12.
24.
What's the first number that I should start with?
12.
12. All right, so now, if I were to keep going, I would get my 24, 36, so on and so forth. But do I need to keep going?
No.
No, because you already recognize that 12 is in both lists. Do you got that?
Yes.
All right, with the people at your table, see if you can do C, D, E, and F. We'll start over here, Lynette, on C. What did you get for the LCM of 4 and 6? She got 12. Do you guys agree?
Yes.
All right, very good. Let's go to D. Aaron,
24.
he's got 24. Now, a lot of you, I'm walking around, you got 3, 6, 9, 12, 15, okay? And then you wrote no, or you left it blank. But this is the one where I said you got to keep going, okay? And eventually you'll get your 24, okay? Let's see. Victor, E. He's got 20. And some people are making the simple mistake of starting with 40. But remember, always start with the number times itself. So start with 20, okay? And then eventually up here you'll get a 20 to match. And F. Alex. He's got 18. Everybody good with that? 18. All right, good job. All right, so what's the difference between LCM and LCD then? What's the other one? LCM and LCD is least common denominator. All right, so the least common denominator is simply the LCM, the least common multiple of the numbers in the denominator. If you are stuck on denominator and numerator, remember denominator is the bottom numbers on a fraction, okay? So just reminders on that, okay? All right, so remember that what we're leading up to is we want to be able to add and subtract fractions together. If you remember earlier, Diana said that if we wanted to add 1/4 and 1/5, we needed to have a denominator of 20 on both, okay? So eventually, if we wanted to add these together, we're not going to do that yet. The very first thing we want to do is just get the same denominator for 2 and 3.
So you multiply 2 by 3 and then 3 by 2.
Okay.
And then do the top.
And the reason is, let's start with this. What is our LCD going to be?
6.
All right, is everybody okay with LCD being 6? If you need help, look at box A. We already said the LCM of 2 and 3. All right, so Alex says that what we want to do then is, in order to get a 6 in the denominator, what would I have to multiply 2 by?
2.
No,
3.
3. So I'm going to multiply by 3, but if I multiply the bottom by 3, I have to multiply the top by 3. Okay? And essentially, I'm multiplying by 3 divided by 3. What's 3 divided by 3? 1. What happens when I multiply something by 1? It's the same number. So if I take 1/2 and multiply by 1, I still get 1/2. The only difference is it's going to look a little different. Okay? I use the analogy, it's like we're taking Clark Kent, 1/2, and we're changing him into Superman. Okay? Same guy, different look. Okay? So now we multiply. What's 3 times 1? 3. What's 3 times 2? Is 3 half of 6. So 3/6 is 1/2. Okay? All right, if we do that with the 2/3, what should we multiply the top and bottom by? 2. I heard 2 and 2. So 2 times 2 is 4. 3 times 2 is 6. So that means the two fractions with the common denominator will be 3/6 and 4/6. And now, later on, if I needed to, I can add them together or I could subtract them because the denominators are the same. Okay? Questions so far? All right, who wants to explain B? Roxana.
You just have to multiply them.
All right. Use the numbers up there. What do you want to do?
1 times 5.
1 times 5?
Over 4 times 12.
4 times,
12. Like, we.
oh, we're not, this is supposed to be a comma. We're trying to find the least common denominator. So what's the least common denominator of 4 and 12, Crossy?
So, multiply 3 by 3.
All right, which one?
1 over 4.
All right, he says to multiply by 3 and multiply by 3. What's the LCD?
12.
I heard 12. So if this is already a 12, do I have to multiply that fraction by anything? No. So Crossy's correct. 3 times 1 is?
3.
3 times 4 gives us our 12. And so now the second fraction basically just stays the same. And now we have the same denominator in both. And now we could eventually add them together or subtract them. Okay? All right, see if you can do C on your own. Marisol, what'd you get for the LCD of 6 and 9? 18. So she multiplied by 3, multiplied by 3, multiplied by 2, multiplied by 2. So what did you get your two fractions to be then?
I multiplied by 3 and
Your first fraction is
3 over
3 over 18,
18.
and your second fraction is 14 over 18. Okay? Questions with that? All right, go to the back side.
I told you.
All right, now we're going to talk about the idea of a factor. Okay? So, on the front side, I talked about the idea of multiples and LCM. Can anybody tell me what a factor is? What's a factor?
Like 2 numbers multiplied equal.
All right, so the two numbers that multiply into that number, okay, so instead of talking about multiplying, we're going to use the idea of a number, Brian, that divides evenly. Into a number. And I'm going to use the hashtag for number because I'm running out of room. Okay? All right. So let's just talk about this idea. I use the word evenly. What does that mean? What does evenly mean?
Even that number, like.
Okay, so how about this, okay? And to help you out, I'll write it down up here, okay? Let's take the number 10. If I say, does 5 go into 10, what would you say? How many times does 5 go into 10?
5.
Exactly 2, or is there leftovers? Exactly 2. So if it goes in exactly 2 times, that's what we refer to as evenly. Okay, there's no remainder, no decimal. So now, what if I asked, does 3 go into 10? Does it go in evenly? Well, it goes in 3 times, but then is there leftovers? There's 1 left over. All right, so leftovers are bad. That means it's not a factor. Okay? So they have to be what we could also call a multiple of the number. Okay? Or, a number that multiplies into the number. Okay? So the GCF. Okay? The GCF, think about this, is the greatest. So that means it is the largest, highest, use any of your synonyms that you want, number that divides into, two or more numbers. All right, so when we look at A, we want to find the factors. Factors are the numbers that go into the number. So that means that they are equal to the number or smaller. Okay, so we're looking for numbers that, for example, are smaller than 10. So can anybody think of a number that goes into 10? Hint, hint, hint. We just used it as an example. 5 is an example, 10 is an example. Can anybody come up with another one? 1 is a factor. Anybody else come up with another one? 2. All right. So I purposely wrote mine the way I did. I like to go in kind of like order. And what I'm essentially doing is I'm thinking 1 times 10 and 2 times 5. So I'm thinking in terms of pairs. Okay? So 1 goes into all numbers. How many times does 1 go into 15? 15. Can anybody think of another number that goes into 15? Diana? 3. 3 times what? 5. So 3 and 5 are the other 2 factors of 15. All right, so now you are finding the largest number in both lists. 5. Notice that the 5 appears in both lists. It's the biggest one. So you're looking all the way to the right, not to the left. So your GCF is 5. It's the biggest number that goes into both 10 and 15. Okay? All right, so let's do this again. 4. I start with 1. 1 times what is 4? 4. Can any other numbers go into 4? 2. 2 times 2. I don't have to write the 2 twice. Okay? All right? 12. I got 1 and 12. What are their numbers? 2 times 6. What else?
3, 4.
All right. What's the biggest number that appears in both lists? 4 is in both lists, so the GCF is 4. Does that make sense? All right. You are on your own for C and D, and then we'll double check and see how you do. Okay? We got to do better with our factors. Okay? We're getting stuck on this. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. Okay? 1 times 54, it's even, so that means 2 goes into it. If 2 goes into it, it goes in 27 times, 54 divided by 2. Hopefully you learned at some point that when the digits get added together, 5 and 4, and get a 9, if 9 is divisible by 3, then that means 54 is divisible by 3. So now, 3 times 18. Okay, and then 54, the last one would be 6 and 9. All right, what's the largest number that's in both lists? 18. Okay, and some of you struggled getting the 18. All right, 27. 1 times 27 and 3 times 9. 72. 1 and 72. 72 is even, so 2 times, Ron, 36. 3 times 24. Okay. Does 4 go into it? Okay. How many times? 18. Does 5 go into it? 6. 12 times. And then the last 2. 8 and 9. We got to get better with our factors. All right, so what's the largest number in both lists? 9. Okay? All right? All right, so, again, biggest thing I'm going to caution you on. When I ask for LCM, you give me the GCF. When I ask for GCF, you give me the LCM. Please make sure you know the difference between the two.